Hello guys, it's my first video in an English language, so you may be see me some stressed and can't to arrange my words, but I hope this video will be helpful for all of you. Hello everybody, my name is Ahmed Said, and in this video I will talk about the bremsstrahlung X-ray. In the previous video I talked about the characteristic X-rays in Arabic language, but in this video I will talk about the bremsstrahlung X-rays in the English language, and in the another video I will talk about this in Arabic language. Bremsstrahlung X-rays are emitted when the electron that ejected from the filament of the cathode that haven't enough energy to eject the electron of the orbit shells of the target anode. So this electron go deeper or travel deeper in the atom to become close to the nucleus and interact with the nucleus, then deflected and emit the X-rays called bremsstrahlung X-rays. Then the bremsstrahlung X-rays are emitted as the electrons slow down in the metal. Incident electron become close to the nucleus, then deflected. Except mammography, 80% or more of X-rays emitted by diagnostic X-ray tube are bremsstrahlung because the target anode material in the mammography is molybdenum, but in other diagnostic processes it is a tungsten material, and this differentiate in the materials create the different in atomic number of the tungsten and the molybdenum. In the tungsten, the atomic number is 74, but in the molybdenum, probably 42. So then the chances of the interact of electron in the molybdenum is less than the tungsten. And I will talk about this in another video with more details. When we apply the electric current, the filament will glowing and heated that make the filament to produce the electrons in the thermionic emission, and I will talk about this in another video with more details too. When the electron arrives at the nucleus, immediately or completely stop or decelerate. At first, the electron loses some of its energy as heat because the interaction of the electron with the outer electron shells in the atom. So when we apply the electrical current, the filament is glowing and heated, then produces the electron in the process called thermionic emission. The electrons lose most of energy as heat because the interaction with the outer shell electrons then go to be close to the nucleus, and when arrives the nucleus, the electrons stopped or decelerated. We told that the electrons lose most of its energy as a heat because the interaction with outer shell electrons. But when the electrons be close to the nucleus, it interact with the nucleus and loses part of remaining energy as a bremsstrahlung X-ray or braking X-ray because the electrons braking or stopped or immediately stopped, and the loss of kinetic energy of the electrons is converted into the X-rays. So the filament is heated and glowing, emitting electrons. Electrons loses most of energy at in the shape of heat because the interaction of the outer shell electrons. And we talk about that these electrons have not enough energy to eject the electrons from the shells. Then it travel deeper in the nucleus, in the atom, sorry, to arrive the nucleus, then interact with the nucleus and deflect and losing the most of or part of remaining energy as a bremsstrahlung X-ray. In this process, each electron produces single photon of energy equivalent to the applied kV. If we apply the tube voltage as 60 kV, the maximum energy of X-ray photons that produces will be 60 kV. Watch that the electrons it approaches fast and leaves less quickly because it loses most of remaining energy at the shape of X-rays. But in this way, from the filament to the nucleus of the atom, it loses some of energy as heat because they interact with the outer shell electrons, and the remaining energy of the electron will be lost in the atom after they interact with the nucleus as an X-ray photons. So it approach fast and leave less quickly. In this process, the electrons lose its energy as 99% heat and 1% X-rays. So the electrons interact with the outer shell electrons but not eject it from the shell and go far or travel far in the atom to reach the nucleus. This process, this way is long to the electron that the electron loses most of energy in this way at the shape of heat. Then when arriving the nucleus, it loses the remaining energy at the shape of X-rays. This shape of X-rays is bremsstrahlung X-rays that produces when the electron ejected from the filament and go to interact with the nucleus of an atom and decelerated and deflected, then produce an X-rays. In bremsstrahlung X-ray, the maximum photon energy is equal the electron energy as we explain in this example. Thank you everybody.